In the last session, we discussed average and RMS values of sinusoidal waveform. Now we will discuss average and RMS values of half rectified waveform. As you can see, the wave shape waveform of a half rectified sinusoidal waveform is like this. From 0 to pi, it is the equation of the waveform is I is equal to Im sin omega t, and pi to 2 pi, it is equal to 0. The equation is written here. I is equal to Im sin omega t in the interval 0 to pi, and I is equal to 0 in the interval pi to 2 pi. To find the average value of this waveform, we can calculate the average value using the equation area under the waveform divided by base. Here, area of the waveform in the interval 0 to 2 pi is 0 to pi. The equation I is equal to Im sin omega t can be integrated from 0 to pi, so that we will get the area under this sinusoidal waveform. And pi to 2 pi, the area is equal to 0. As you can see here, it's equal to 0. Divided by the base. Base is 0 to 2 pi because this waveform repeats in the interval 2 pi. So 0 to pi I d omega t divided by the base is 2 pi. Integral 0 to pi Im sin omega t d omega t divided by 2 pi. Im by 2 pi can be taken outside. Integral sin omega t d omega t is minus cos omega t in the interval 0 to pi. So we can apply the limits 0 to pi. Minus Im by 2 pi into cos pi is minus 1, cos 0 is 1. So you will get minus Im by 2 pi into 2, minus 2, that is equal to Im by pi. The average value of this waveform, that is half rectified sinusoidal waveform, is equal to Im by pi. Now we can calculate the RMS value. RMS value is calculated as area under the squared waveform divided by base and taking the square root of that. That is square root of area under the squared waveform. For that we are taking 0 to pi I square d omega t divided by base is 2 pi. Root of mean of squared value. That is root mean square value. So you can write as root of integral 0 to pi. Instead of I d omega t in case of average value, here we are taking I square d omega t. I is equal to Im sin omega t the whole square into d omega t divided by the base is 2 pi. That is equal to root of Im square by 2 pi integral 0 to pi sin square omega t can be written as 1 minus cos 2 omega t by 2 d omega t. That is equal to root of Im square by 2 can be taken out. Im square by 4 pi into 1 minus cos 2 omega t can be integrated as omega t minus sin 2 omega t by 2 in the interval 0 to pi. We can write it as root of Im square by 4 pi into omega t minus sin 2 omega t in the interval 0 to pi. You can apply the limits. Root of Im square by 4 pi into pi minus sin 2 pi 0 minus for omega t we are giving 0, then sin 0. You will get root of Im square by 4, that is equal to Im by 2, the RMS value of the waveform. Rectified sinusoidal waveform is Im by 2. Now we can calculate form factor and peak factor for this waveform. Form factor we have discussed as RMS value divided by average value. RMS value we found it as Im by 2 for rectified sinusoidal waveform, and the average value is equal to Im by pi. So form factor is equal to Im by 2 divided by Im by pi, which is equal to pi by 2. Now coming to peak factor. Peak factor is equal to peak value or maximum value divided by RMS value. Peak value is Im and RMS value is Im by 2. So it is equal to 2. Peak factor is equal to 2.